Now the class is going for SE students, and I have selected the questions from chapter 4. Okay students, you copy the questions number 2, 4, 6, 8, 10, 12, 14 and 16. Actually these questions will be asked in 1 marks in SE. Okay, let me start. Question number 2. Write the relationship between acceleration due to gravity and radius of the earth. Okay, do you know the answer? Right. So the relationship between acceleration due to gravity and radius of the earth is inversely proportional to each other. What do you mention? Inversely proportional to each other. That's it. Now we are in question number 4. What is an acceleration due to gravity? What is an acceleration due to gravity? So what is the answer? The acceleration produced on a freely falling body. The acceleration produced on a freely falling body due to force of gravity of a heavenly body. Due to force of gravity of a heavenly body is called acceleration due to gravity. Now question number 6. What is free fall? What is free fall? Answer: the falling of a body freely, towards the center of a heavenly body, in the absence of air resistance. In the absence of air resistance is called free fall. The falling of a body freely towards the center of a heavenly body, in the absence of air resistance is called free fall. Question number 8. Write the formula to find the weight of an object. So here you will have to write the formula. Weight of the object, W equals to capital G, capital M, small m by R square. W equals to capital G, capital M, small m by R square. Or you can write W equals to m times G, small g. Okay students, now question number 10. Question is, what is the value of small g on equatorial region and polar region of the earth? Value of small g on equatorial region? Sorry? Oh, question number 10, yeah. What is the value of universal gravitational constant? Good, I was reading question number 9. You know the value of universal gravitational constant is 6.67 times 10 to the power minus 11, not minus 11. 6.67 times 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. Okay. So if you are disturbing others, please mute your audio. Question number 12. What does it call if an object falls without any external resistance? If an object falls without any external resistance, then it is called free fall. Okay, now students, we are in question number 14. What is acceleration due to gravity? What is acceleration due to gravity? Do you know what is the answer? The acceleration produced on a freely falling body. The acceleration produced on a freely falling body due to force of gravity of the heavenly body. Due to force of gravity of the heavenly body is called acceleration due to gravity. Now we are in question number 16. What is gravitation? Gravitation is defined as the mutual force of attraction between any two bodies in the universe. The mutual force of attraction between any two bodies in the universe. Okay, students, we have discussed some questions of very short answer type. Now, let's discuss about short answer type questions. It means such type of question will be asked in 2 marks. Alright. At first, let's discuss here. In very short, we have discussed even. Now we will be discussing odd. What does question number 1 say? Question number 1 says, Kathmandu lies at high altitude than Viratnagar from sea level. Where does an object has more weight between two places? Give reason. What do you think? The weight will be more in Kathmandu or Viratnagar? Viratnagar. So, yeah, okay. The weight will be more in Viratnagar because Viratnagar lies in less altitude and Kathmandu lies in more altitude. Viratnagar lies in less altitude and Kathmandu lies in more altitude. Again, you can write the value of small g. The value of small g is inversely proportional to altitude. The value of small g is inversely proportional to altitude. Okay, my dear students, now we are in question number 3, short answer questions. What does the question say? Illustrate the relation g proportional to 1 by r square with an example. So this question is derived type of question. So where is the relationship? You can show the relationship by looking the book page number 15. In my book it's in page number 15. It's given relation of acceleration due to gravity with the Earth's radius. Please check in your book whether it is in same page or different page. So you have to start from let m be the mass of the Earth to the acceleration due to gravity of the Earth is also inversely proportional to the square of its radius. Did you get it, students? So you must not forget to draw the diagram. Diagram is important. Okay, students. Now we are going in question number 5. Question number 5 says, how much is the weight of a body less on the moon surface than on the earth surface? Why? Question says, how much is the weight of a body less on the moon surface than on the earth surface, and why? Do you know? The weight of a body is 6 times less on the moon surface than on the earth surface. What should be your answer? The weight of the body is 6 times less on the moon's surface than on the earth's surface, because the acceleration due to gravity of the moon is 6 times less than that of the earth. Acceleration due to gravity of the moon is 6 times less than that of the earth. Next point you can write, g, small g on the earth equals to 9.8 meter per second square. Small g equals to 9.8 meter per second square. The same way, small g on the moon equals to 1.67 meter per second square. 1.67 meter per second square. Okay, students. Now let's discuss question number 7. Write any two differences between gravity and acceleration due to gravity. I have reminded many times, you have to draw a very attractive diagram, means table. Left hand side write down gravity. Right hand side you can write acceleration due to gravity. And there must be two places for differences. Point number 1, point number 2. Okay, left hand side, gravity. Definition of gravity is the force with which a heavenly body pulls an object towards its center is called gravity. Now, acceleration due to gravity. The acceleration produced on a freely falling body, due to force of gravity of the heavenly body. Due to force of gravity of the heavenly body is called acceleration due to gravity. So in first number, what we have done, we have given the definitions. Now in second point, the SI unit of gravity is Newton. SI unit of gravity is Newton. Next side, SI unit of acceleration due to gravity is meter per second square. What it should be? Meter per second square. Okay, students. Now we are in question number 9. Question number 9 says, astronauts feels weightlessness in a spacecraft. Why? Astronaut feels weightlessness in a spacecraft because there is no force of gravity. No, who is talking? Now here are some students. Some students who are disturbing, please don't disturb. Because there is no astronaut feels weightlessness in a spacecraft because there is no force of gravity. Or you can write there means there the value of small g is 0. You can write, what can you write? The value of small g is 0. Acceleration due to gravity is 0. Okay? Students, question number 11 says, what happens to the weight of an object when it is taken from Earth to the Moon. Why? Just mark it. Weight. What happens to the weight of an object when it is taken from Earth to the Moon? Its mass decreases how many times? 6 times. Okay. When an object is taken from Earth to the Moon, then its weight is decreased 6 times because the acceleration due to gravity of the Moon is 6 times less than that of the Earth. Okay? The weight of the object decreases 6 times when it is taken from Earth to the Moon because the acceleration due to gravity of the Moon is 6 times less than that of the Earth. G is less, weight also becomes less. Yes. Okay students, now we are in question number 13. I hope everybody is together with us. 13 question number says, under which condition the weight of gravitational force and gravitational constant become equal? When force and gravitational constant become equal? Okay, do you know the answer? The value of gravitational force and gravitational constant become equal when, number 1, mass of each body is 1 kg. Point wise you have to write, okay? Mass of each body is 1 kg. Second point, distance between the bodies is 1 meter. Distance between the bodies is 1 meter. Okay, lovely students who are going to be alpha, deserving GPA 4, there is no doubt. Please try. Nothing is impossible. Just you try. You can achieve it. Question number 15 says, the value of universal gravitational constant is 6.67 times 10 to the power minus 11 Newton meter square per kg square. What does it mean? In the surface of Moon, the value of body is less than or why? In the surface of the Moon, the weight of body is less than, not value, the weight of body is less than or why? This question says value, weight it should be. Okay, question says, the value of universal gravitational constant is 6.67 times 10 to the power minus 11 Newton meter square per kg square means the two bodies of unit mass are kept at a distance of 1 meter. Two bodies of unit mass are kept at a distance of 1 meter, and the force of attraction between them is 6.67 times 10 to the power minus 11 Newton. 6.67 times 10 to the power minus 11 Newton. That is force. That's a Newton only you have to write, okay? Alright students, now we are in second part. In the surface of the Moon, the weight of body is less than Earth because the acceleration due to gravity of the Moon is 6 times less than that of the Earth. 6 times less than that of the Earth. Acceleration due to gravity less, weight also less. Okay students, question number 17. The acceleration due to gravity on the surface of the earth is 9.8 meter per second square. What does it mean? Write the main conclusion of Galileo's feather and coin experiment. Okay, first part answer. The acceleration due to gravity on the surface of the earth is 9.8 meter per second square means the velocity of falling body changes. The velocity of falling body changes at the rate of 9.8 meter per second in the earth. Sorry? In every second. 9.8 meter per second in every second in the earth. Yeah, in every second this thing. Good. And next is, write the main conclusion of Galileo's feather and coin experiment. The main conclusion of Galileo's feather and coin experiment is the acceleration of freely falling bodies is the acceleration of freely falling bodies is independent to their masses. The acceleration of freely falling bodies is independent to their masses. Sorry? Now question number 19 is already done, so no need to do this one. Okay students, now we are discussing next portion, that is long, yeah, even now will be even. Shreya, will you read the question, Babu? Okay, students, while solving such type of questions, sometimes similar question we have discussed earlier, so I'm not going to discuss those questions, but you have to write. What do you have to do? You have to write. I have reminded many times. If you know, write one time, and if you don't know, find out and write 3 times. Okay, question number 2, solution. The acceleration due to gravity on the surface of the Jupiter is 25 meter per second square means the velocity of freely falling body changes at the rate of 25 meter per second in every second in the Jupiter. 25 meter per second in every second in the Jupiter. So some who are making their video on, I can see they are writing, like Rajati is writing, but others who are hiding, I didn't think that they are writing. So Soeb is writing. Biru is not using his kambal today. I think he is feeling hot, right? Oh, still he has got. And Roshan and Niraj, they are doing. Okay. Students, now let's discuss next question. Let me share again the screen. So after sharing the screen, we can check what is there. Now we will be discussing question number 4. Question number 4. Okay, what does question number 4 say? So, do you know the question? So, question is coming. I think question is moving here and there. Why? Okay, students, question number 4. Question number 2. Next part question is there. Write the reason behind the atmosphere does not escape away from the earth. The reason behind the atmosphere does not escape away from the earth because of high gravity. Because of high gravity. The gravity of the earth is very high. For 1 kg mass, it applies 9.8 Newton. That's more. But atmosphere does not exist on the moon because there the value of gravity is very low, 6 times less than that of the earth. Okay, students. Next question: differences between gravity and acceleration due to gravity. Have you written earlier? Already done. Okay. Now let's go to question number 4. Will you read question number 4? What does the question number 4 say? Capital G, small g. And second is the weight of a body is more at polar region than at equator give regions. Okay, students. Do you know the differences between capital G and small g? Okay, left hand side you can write capital G, right hand side small g. So capital G is constant. So one information was shown, it will go after 10 minutes, but again you can send me the request, I will accept you. Okay, capital G is constant, small g is variable. Second point, the value of capital G is 6.67 times 10 to the power minus 11 Newton meter square per kg square. And next point, the value of small g on the earth is 9.8 meter per second square. The value of small g on the earth is 9.8 meter per second square. Students, you can give the definition also. It doesn't mean that what I have said that is enough. You can give more, right? Students, now we are in question number 6. Question says, not completed. Okay, please, you complete. So writing is very important. So how much fast? Sorry. Next part. Okay, the weight of a body is more at polar region than at equatorial region. Why? The question is not seen clearly. I think you can see here. The weight of a body is more at polar region than at equator give region. So you can write the weight of a body is more at polar region than at equator because the value of small g, at polar region is 9.83 meter per second square. 9.83 meter per second square, and the value of small g at equator is 9.78 meter per second square. One is 83, another is 78. Done? I hope you have done it now. Let's do number 6. Question number 6 says, in which factors does gravitational force depends? It should be depend. In which factor does gravitational force depend? So the factors on which gravitational force depend are, you can write point wise, masses of the heavenly bodies, masses of the heavenly bodies. Second one, distance between their center. Okay. Next one is write any two differences between acceleration due to gravity and universal gravitational constant. So such type of question solution we have done in question number 4, capital G and small g. Okay, you can do it. Now students, we will go to next portion. In next portion, what is here is given very long type questions. Very long type question is there. Now, not seen. Now, can you see? Now not seen. Check it. I have just marked it. It is quite visible in my screen. I think in your screen also it might be stretched, right? Students, question number, which one we have to do here? Even or odd? We have to do odd, right? Odd, yes or no? Okay, question number 1. Read the question. Here are two figures. One is Earth surface and another Moon surface. Small g is given 1.62 meter per second square on the surface of Moon and 9.8 meter per second square on the surface of Earth. Now, what is the next thing? In the figure below, two identical metal balls A and B having equal masses are being dropped towards the surface of the Moon and Earth. Mass is same, height is same. Analyze the given data and answer the following questions. If both the metal balls are released simultaneously, which one does strike the ground faster? Which one strikes the ground faster? A or B? Sorry? B strikes the ground faster because acceleration produced on it will be nearly 6 times more than that of the Moon. Okay? More small g, faster its movement. Question number B. Can you read the question? A person lifts 30 kg on the surface of the Earth. How much mass can he lift on the surface of the Moon if he applies same magnitude of force? Okay, my dear students, I have said you many times this question solution. Let me find out where it is. Page number. Did you find it? The Biru, what is the page number? Yeah, so it is in the chapter 4. So you find out. Others also you can find, not only Biru. Others also you can just go through it. Like Soeb, Rajaki, Srijan, Pooja, Lead King, Terodai, Biswajit. Where is found? In my book, it is in page number 20, right? Example 4. Example? So the example number 4, right? A person can lift, it is given there. So, example 2. Okay, so you have to complete that one, right? Can you do? Don't copy same, do similar one. Okay, students. Now we are in question number 3. We'll read the question. Question. So, tides rise on the sea. Why? Tides rise on the sea due to force of gravity of the Moon. Due to force of gravity of the Moon. Okay? Number second part. What is weightlessness? Can you write it? Weightlessness is the condition at which the weight of a body becomes zero, and prove that the acceleration due to gravity is independent to the mass of falling body. So which one you have to prove? So that one is page number 15. Is there page number 15? G inversely proportional to 1 by r square. G inversely proportional to r square. Did you get it? It was said earlier also, now also it is repeated. Okay, students. So we have just done 1 marks, 2 marks, 3 marks and 4 marks question, right? Now it's the turn to do some numerical problems. Question number, which one to do here? 2, right? Okay, will you read the question? What is given? Mass of the earth is given, mass of the moon is given, distance between them is given, and capital F is also given. So we have to calculate gravitational constant. See? So let me read the question once. Mass of the moon and the earth are 72 times 10 to the power 21 kg and 6 times 10 to the power 24 kg respectively. The distance between the moon and the earth is 36 times 10 to the power 6 meter. If the force of attraction between these two bodies is 2.2 times 10 to the power 18 Newton. Okay, students, I think 40 minutes time is already completed. It has said to do again. I'm going to conduct the meeting. So this is the system. So in Zoom, after 40 minutes, we have to conduct new meeting. The students, they are coming. And I was doing question number, this has come, video has come, Lead King also has come. Let me share the question. So students, what is given? You can write M1, M2, D, and later on, still they are coming. Just the next question I will just show you, Babu, because I was just sharing it. That's why it became like this. Good. Okay. So students, you just underline 72 times 10 to the power 21 kg as M1. 6 times 10 to the power 24 kg as M2. 36 times 10 to the power 8 meter as D. What to write there? D. And 72 times 10 to the power 21 kg, no, 2.2 times 10 to the power 18 Newton as F, capital F, and capital G equals to what? Which formula is applicable here? Do you know? Capital F equals to G, capital G M1 M2 by D square, or you can write the next formula, capital G equals to, remember, capital G equals to FD square by M1 times M2, or M1 M2 you can write. Capital G equals to FD square by M1 M2. So can you solve it? You can do, and the value will come in Newton meter square per kg square. Remember, the value of acceleration due to gravity is constant. And next thing, this question's answer is already out because the value of capital G is constant. So what should be its answer? 6.67 times 10 to the power minus 11 Newton meter square per kg square. Got the idea? Now students, let's go to number 4. We'll read the question. What does it say? The gravitational force produced between two bodies is 25 Newton when they are at the distance of 4 meter. How much gravitational force is produced when they are kept 2 meter apart? Calculate, it is saying. I told you many times, first read the question, underline it and find out the given things. So what is given? 4 meter. 4 meter is D1. Please underline that, D1. 25 Newton is W1. Okay. D1 is 4 meter. 25 Newton is W1. 2 meter is D2. And you have to find out W2. Do you know the formula? Very simple formula is here. Formula is W2 by W1. W2 by W1 equals to D1 square by D1 square, not D1 by D2. D1 whole square by D2 whole square. Please keep in mind. W2 by W1 equals to D1 square by D2 square. Now you substitute the value of given quantities, you will get D2. Sorry, W2. Okay? And students, don't forget to write the answer in sentence at last. What should be the answer? Therefore, the gravitational force produced between these two bodies is that much Newton. Here you can write W1 by W2 or F1 by F2 also you can write down. No problem. Now students, we are going to discuss question number 6. Question says, mass of the earth is 6 times 10 to the power 24 kg. What is the value of acceleration due to gravity of an object which is at a distance of 19,200 km from center of the earth? Okay. So students, first of all, mark it. Underline 6 times 10 to the power 24 kg and write capital M. What is that? Capital M. And acceleration due to gravity, G prime equals to what? G prime equals to what? The distance of this much from the earth means that is D, small d, distance D equals to that is 19,200 kilometer. But that kilometer must be converted to meter. Okay? Converted to meter. How to convert meter? Very simple. Multiply by 1000. Then which formula is applicable here? Small g prime, g dash equals to, please write down, g dash equals to capital G, capital M upon or by d square. D square. Now you will get the answer easily. Can you get or not? And finally write down the acceleration due to gravity of the object at that distance is this much meter per second square. Answer must come in meter per second square. Now we are in question number 8. What does the question say? Somebody has ticked it. It is very good. If two bodies are kept at a distance of 400 meters, the gravitational force between the bodies is 4.16875 times 10 to the power 4 Newton. The mass of the one of the body is this much kg. Find the mass of another body. So students, this 400 meter is D. Underline that and mark it. and 4.16875 times 10 to the power 4. That is capital F. 2 times 10 to the power 7 kg. That is M1. Capital G is given, gravitational constant. Then what to calculate? Do you know? You have to calculate M2. You have to calculate M2. So which formula is suitable here? Capital F equals to, remember, G M1 M2 by D square. Okay? Yeah, please substitute the value and get the answer. It is very important. You must get answer correctly. After some time I will ask you to complete it and you have to present here. Now question number 10 is also similar. No need to do similar questions. Now let's go to another one. Next question is here. Now long type questions. Sometimes they may ask you in 3 marks. Okay. Friends, let's discuss question number 1. Will you read question number 1? Not seen? Has it come? Now? Has the question appeared in your screen or not? Till now no question? Will you check? Biru, is there a question? Rajaki? There is question or not? Now can you see question? Okay, Biru, read the question. Number 1. Good. So which formula will be suitable over here? So 1.9 times 10 to the power 30 kg, that is M1. 2 times 10 to the power 30 kg, M2. And capital F is 4.3 times 10 to the power 29 Newton. Capital G is given. What is the value of capital G? 6.67. Good. And you need to calculate D. So which formula is applicable here? F equals to G M1 M2 by D square. Now you have to use the formula, this one. D equals to, small d equals to root under F by G, root under F by G M1 M2. Is it? Is that formula? D square, no, listen. Root under D equals to, remember the formula, root under, D equals to root under G M1 M2 by F. I said wrong formula earlier. Write down please. D equals to root under G M1 M2 by F. Okay? You got the idea? Now we are in question number 3. Question number 3, who is going to read? Shoaib will read the question number 3. Okay. Now first one. 72 meter. Underline it, write X. 6 seconds. Underline it and write T. Okay. So we are dropping something means initial velocity is 0. Now write down solution given initial velocity u equals to 0, height h equals to 72 meter, time small t equals to 6 seconds, acceleration due to gravity small g equals to 9.8 meter per second square, 9.8 meter per second square. You have to find out small g. Don't write that one. Question says calculate acceleration due to gravity, isn't it? Small g equals to what? What formula you have to use now? Okay, small g equals to what? According to formula, write down h equals to, formula is h, height h equals to ut plus half gt square, ut plus half gt square. If you solve it, you will get the value of g. The answer must come 9.8 meter per second square. Let's see. Question says, second part, at what condition does the acceleration due to gravity become 0? The acceleration due to gravity becomes 0 during free fall. What do you mention there? During free fall. Okay. Alright students, there are many numerical problems. So these problems I will keep I have already kept in the group, but you said you could not see it. Once again I will just click it and do. Now finally one more question I am going to guide you. Number 10. Question number 10 now, okay? Will you read the question? Acceleration due to gravity varies according to places of the earth y. When a feather and a coin is dropped towards the surface of the earth, do they reach the ground together? If this experiment is done in moon, what difference can be occurred? Write with reason. The distance between earth and moon is this much meter. If the mass of the earth is kg, meter means 36 times 10 to the power 6 meter, 6 times 10 to the power 24 kg, and mass of the moon is 7.2 times 10 to the power 22 kg. What the gravitational force between them? Students, now answer. Acceleration due to gravity varies according to places of the earth because the earth is not perfectly spherical. The earth is not perfectly spherical. The radius changes from place to place. Radius changes from place to place. It's completely right. Next question. When a feather and a coin is dropped towards the surface of the earth, do they reach the ground together? Together. When a feather and coin is dropped towards the surface of the earth, they do not reach the ground together. The coin reaches the ground faster. The coin reaches the ground faster. Finish. If this experiment is done in moon, what difference can be occurred? If this experiment is done in the moon, then both of them will reach on the ground together. Both of them will reach on the ground together because there is no air resistance. Where? On the moon. There is no resistance. There is no air resistance on the moon, and the body has free fall. The body has free fall in the moon. Now next question is given, your distance is 336 times 10 to the power 8 meter. M1 is 6 times 10 to the power 24 kg. M2 is 7.2 times 10 to the power 22 kg. Capital G is given. Then what is the formula? Students, can you say? The formula is capital F equals to G M1 M2 by D square. G M1 M2 by D square. So students, you have to practice this type of sums more and more so that you can do something better. So now your time starts. You do these sums as much as in short period of time, and you have to present in tomorrow's class. So these questions will be shared. I will share the questions in your messenger group again by clicking small portion so that it will be easier one. Okay? So students, are you practicing a lot? Are you practicing a lot or not? So everybody must practice and try to deserve GPA 4. So today this much. See you tomorrow. Till then, bye bye.